right, so today we're going to look at the final topic that we are going to cover about matrices, and this is inverses of matrices. It's going to tie in a lot of what we did yesterday, so that'll give us some extra practice at doing that whole row echelon form. Okay, so let's go ahead and jump right in. Okay, before we talk about inverses, we need to talk a little bit about identities. So an identity matrix, it's a special matrix that we have several uses for. But before we even talk about it, let's go back and think about in Algebra 1, we used to have this term that we used to talk about a lot, the multiplicative identity. The multiplicative identity is the value that you can multiply by and multiply by a number and get the exact same thing. So think about that. What would that value be? What can you multiply by and get the exact same thing? Well, it would be a 1. All right, we can multiply by 1. That's the multiplicative identity. Now, an identity matrix is the same thing. For the identity matrix, and we usually label an identity matrix I, all right, in order for it to be truly an identity matrix, you should be able to take any matrix A, and I should say this would be the identity matrix for a particular sized matrix. But you should be able to take matrix A and multiply it by the identity matrix and still end up with the same matrix A. And it should work both ways. I should be able to take the identity matrix times A and still get the same matrix A. Now, in order to be able to do that, there's got to be, in this identity matrix, not a lot going on. So it typically will consist of 1s on the main diagonal and 0s every place else. And I say typically, but I mean like always. That's what the identity matrix is. You have to have 1s on your main diagonal, 0s everywhere else. It's sort of like that row echelon thing we did yesterday. Okay, so this is asking us here. There's a little example. Give the 3 by 3 identity matrix, I3 is how we'd label that, and show that when you take matrix A and you multiply it by the identity matrix, that we're going to still end up with the same matrix A. So let's give it a shot. I'm going to multiply it by the identity matrix, and since that's a 3 by 3, I'm going to do a 3 by 3 identity matrix as well. Okay, so there's your identity matrix. And this is actually kind of a nice little review of multiplying matrices. We haven't done this for a few days. So remember that this first one is a 3 by 3. And this identity matrix is 3 by 3. So we are allowed to multiply these because the 3's match, and my resulting matrix is going to end up being another 3 by 3. So here I go. I have another 3 by 3 is going to be my result. And remember that to find this value in this matrix, this is the first row, first column. So you take the first row times the first column. So that means you're going to take a -2 times 1. That's going to get us a -2. 4 times 0, 0 times 0. So really, those are just going to cancel it out, and all I'm going to have is this -2. So that would be this first value. To get the first row, second column, I take first row times the second column. Now look at what you're doing here. You're going to take this -2 times 0, 4 times 1, 0 times 0. The only thing that's going to get us anything is this 4 times 1, and that's going to get us a 4. All right, first row, third column. First row, third column. Now, you can start to get the hang of this whole idea of what's going on. Is this is going to get multiplied by a 0, so is this. So the only thing that's going to get me a value would be this last one, which conveniently happens to be a 0, but it wouldn't have to be. So there we go. All right, let's try it one more time here. Let's try second row, second row. So second row, first column. So second row, first column. When you take this times this column, notice these zeros are going to cancel out the 5 and the 9, and all I'm going to have is that 3. But if I move to the second column, now when I take this times the second column, you can see that the first and last digits, the 3 and the 9, those are going to get canceled out, and all I'm going to have is that 5. All right, last one that I'm going to do here, I'm going to take this times the last column. Again, 0 is going to cancel out in the 3 and the 5. All I have left is that 9. And you can see I'm starting to build this matrix that happens to be identical to this matrix. And I'm going to stop, but I could keep on going. I could go ahead and multiply that last row, and I'd end up with the 0, 8, negative 6 there. Okay, so that's how the identity matrix will work. Now let's talk a little bit about inverse matrices. Now, from Algebra 1, we learned about inverses, and it was a property, and we learned that for inverses, to be multiplicative inverses, two values have to multiply to equal your identity. That's a multiplicative inverse. So in this case, if I take a 5 times a 1/5, that actually ends up equaling 1. And since 1 is the multiplicative identity, that would make these two be inverses. All right, the order that I multiply them shouldn't matter. It should work both ways. I still get this identity of 1. The idea works the same on matrices. If I take some matrix A and I multiply it by its inverse matrix, these two should multiply to end up equaling my identity matrix. And it should also work the other direction. Still should multiply to get the identity. Let's look at a little matrix, just a 2 by 2, to show you what I mean here. If I take matrix A, and I conveniently have also already told you what the inverse of it is, and I multiply those two together. So I've got my 1, negative 2, 1, negative 1. I am going to multiply this by its inverse. And if I multiply it, it should end up giving me this identity matrix. Let's give it a shot. This is a 2 by 2. This is also a 2 by 2. So yes, I can multiply them, and my end result will be another 2 by 2. To find the first row, first column, I'm going to take first row times the first column. So that's a negative 1 and a positive 2. That's 1. First row, second column. First row, second column. So that's going to get me a 2 and a negative 2. Those cancel out to 0. Now I'm going to do second row, first column. So that's going to be a negative 1 and a positive 1. Those combine to 0. And second row, second column, that's going to get me a 2 and a negative 1, and that's a 1. And lo and behold, look at what I got. I have the identity matrix. That's what I wanted to have happen. Okay, now I could go ahead and I could do it the other direction. I'm not going to take the time to do that. But for this to truly be an identity, it should also work the other way, where I put this one before this one and did the multiplication. Really, what I want to talk about with that, though, is if this is supposed to work both ways, let's talk about what kind of matrices would work to do that. The only way to get these matrices to be able to be even multiplied in the first place would be to have these two values be the same. And for this to work out, for this version to work out, this would have to be in front of it, which would actually swap it. These would have to be the same. And in the end, the only way this will ever work is if you have a square matrix. A 2 by 2 could work, but a 2 by 3 would not, because when you brought this over here, it wouldn't necessarily multiply. So square matrices are where it's at. Just a few rules about this, and just to kind of reiterate some of the things I've already said there. So A is going to be a n by n matrix. So notice n by n. Rows and columns are going to be the same. So only square matrices even have inverses that we're going to even be looking for. Now, just as a side note, not all square matrices have an inverse. Now, I'm not going to probably mess with getting into all of that, but only square matrices would even work to do this with. And If it truly is going to be an inverse, then you should be able to multiply this direction and get your identity matrix, but you should also be able to multiply the other direction and get that identity matrix. And just a little bit with notation, this little -1, just like when we talk about inverse functions, that little -1 superscript is going to be indicating that it's the inverse, and we read it A inverse when you see this, A inverse. Now, with all of that, the thing that's kind of that I haven't really drawn attention to yet, that's kind of an important thing, is I've always given you what the inverse is. Really, what our goal today is mostly going to be to, how do you find that inverse? Okay, so for this multiplication to work both ways and to end up with an I, we have a little strategy we have to find the inverse. The first thing you're going to do is you're going to set up an augmented matrix. An augmented matrix is what we had yesterday, and the augmented matrix, and actually it's right down here. I don't know why I have it up there also. This is going to be your augmented matrix. You're going to take the A matrix that is given to you. You draw in this line here, and then you're going to put the identity matrix. So this is going to be kind of a long one, because this could be like a 3x3 and another 3x3. So different sized matrices that we'll deal with. Then what your goal is to do all that row echelon work that we did yesterday and convert this matrix into this matrix. If you can sit there and do all your rules that we've been doing to take this A matrix and turn it into an identity matrix, which is really what we've been doing, right? To solve the system, that's what we did. It ended up being a 1, 0, 0, 0, 1, 0, 0, 0, 1. It was the identity matrix. We just didn't call it that. So we're going to do all those same rules, get the identity matrix on the left, and what you have left over on the right side, that's the inverse matrix. Let's try one. Once you realize that this is what we're doing, that we're following this little rule here, then all we're doing is kind of a repeat from yesterday. But the numbers are going to be a little nicer today, I promise. Okie doke. So here we go. They're going to give me a matrix. Here it is. Remember, it's got to be a square matrix. We're going to do a 3x3 because we're feeling good. 3x3 is on the left, identity matrix on the right. All right, I am going to write this really little because all of that has to fit in this matrix. Now, I have chosen here today to go ahead and just give you some blanket matrices here. You've got all the rules. Just because I don't want to restrict you too much, now that you know how this works, if you have your own strategy, maybe you want to swap some rows or divide a row by something, I've given you an extra matrix in here to allow to do that. Now, so you may or may not use all of the matrices. I know that we definitely are not going to be using all of the lines for the rules. We won't need them all. So here I go. First thing, let's write the matrix on the left. Maybe watch what I'm doing here so you can plan ahead on your spacing. It's going to look like this on the left. And then you draw that bar. This is your augmented matrix. And then you're going to put the identity matrix that looks like this. The next step is to start working on getting this matrix, or getting this side, I guess, to look like this. So remember how we do that? We work on the first column and we're working on zeros. I don't care about the ones yet. Just work on the zeros. So I need a rule for row 2 and I need a rule for, oops, I should really be looking here. I need a rule for row 2 and a rule for row 3 to get these two to turn into zeros. I'm not going to be using this first one. So since I'm not changing the first row, if I want to go ahead and fill in the first row, I can certainly do that. Now, the second row. We may not all agree on what the rules are. That's okay. I guess I'm just going to make them up because I can't hear what you're saying. So here we go. As far as coming up with a rule for row 2 to turn this into a 0, I think the thing that jumps out at me is probably row 1. I'm going to do a row 1 minus row 2. That's going to be my rule. So then I get 1 minus 1 is 0. Negative 1 minus 0. 0 minus negative 1. And then I keep on going. I just keep on going with the same thing. Row 1 minus row 2. So 1 minus 0, 0 minus 1, and 0 minus 0. Now let's look at a rule for row 3. I want to turn this 6 into a 0. So I could group it with either one. I kind of like the 0 sitting there. That might be easy. So I think I'm going to group it with row 2. So I am going to make row 2 be a negative 6. So negative 6 row 2, add it to row 3. Just a quick reminder that when you're picking these rules, you can never choose the same 2 rows for both rules. So I've got a 1 and a 2 here, and a 2 and a 3. So those are different. I'm going to be good. Here we go. Negative 6 times row 2 plus row 3. That's going to be a 0. Then I'm going to have a negative 6 times 0, add it to row 2. Negative 6 times negative 1, so that's a 6 plus a negative 3. Then I keep on going. This is going to be 0 plus 0. This is going to be negative 6 plus 0. And then the last one is going to be a 0 plus a 1. There we go. Now, something to note here. I decided, like, even though this all went up here, and typically I wouldn't really want that guy right there to be a 0. But so you might have chosen, and this is why I gave you extra matrices, you might have chosen to rearrange. Maybe you would want to put this one up here and put this one down here. You might have swapped row 1 and 2. I didn't even mention that. I should have, because that certainly would be a good option. Sometimes I just jump in and I just go through the motions. I don't know if that's smart or not. I could definitely do some shortcuts if I took the time to do that rearranging. I probably should have, but I'm this deep. I'm going to keep going. I have now, I'm working on the second column, and I want the top and the bottom to be zeros. So that means I want this and this to be zeros. So I'm going to have a rule here and here. I'm not going to have a rule in row 2. I'm not going to change anything in row 2. So let's work on row 1. If I want to take this and I want to turn it into a 0, I could group it with either one of these, though I feel like this one might be easier. So I'm going to do, let's see how I want to write this. I'm going to do negative row 2, and then I'm going to add it to row 1. It's going to look like that. So that would be negative 0 plus 1. Then I'm going to have a positive 1 plus a negative 1. There's that 0 I wanted. Then I want negative 1 plus 0. Negative 1 plus 1. Positive 1 plus 0. And 0 plus 0. All right, next thing I'm going to do is I'm going to turn this negative 2 into a 0. I don't really have options. I sometimes ask, what rule do you want to make? But I'm going to tell you what, you don't really have options here. When you get this far in and you've already got some zeros created, you have to be careful that you don't lose those zeros. So if I decide to write a rule here that includes row 1, this 1 right here is going to mess up the 0 I already have. So right now, and for now on, I'm kind of restricted. I've got to only use rows that have zeros at least where my existing zeros are. So in row 3, since I have a 0 here, I can only group it with other rows that also have a 0 there. So row 2, I cannot group it with row 1. So I'm going to do something with row 2 and 3. I want this to be a 0, so I think I'm going to take negative 2 times row 2. -2, row 2, add it to row 3. All right, I'm going to end up with a 0. Then I'm going to have a +2 plus a -2. Then I'm going to have -2 plus 3, -2, -2 plus 0. That's going to be a +2 plus -6. And then I'm going to have a 0 plus a 1. Okay, this is looking good. I've got my zeros and my 1 here. All I've got left is this last column. And in the last column, I want these two to be zeros. So that means I'm going to be writing a rule here, writing a rule here. I'm done with this row. I'm so done, I don't even have to mess with dividing by anything. It's already a 1. So I'm getting super lucky here. 0, 0, 1, -2, -4, 1. That's not going to change. Now let's come up with a rule. And remember what I said, if I'm going to come up with a rule to try to turn this into a 0, I can only combine this row with another row that would have a 0 in this spot. It's going to be row 3. And in fact, I'm going to get stuck on this one, only be able to work with row 3 as well. On your last matrix, you will always be grouping with row 3. All right, to turn this one into a 0, I'm just going to add the row 3. So I'm going to write it like this, row 3 plus row 1. Just adding those two rows together. I can do that very quickly. Got it. Okay, I love that rule. That's a fast one. Okay, now I'm going to work on getting this to be a 0. And again, I can only group it with row 3. So I'm going to say row 3 minus row 2. Right, this is going to be another one that's pretty quick and easy. Row 3 minus row 2. 0 minus 0, 0 minus -1, 1 minus 1, -2 minus 1, -4 minus -1, and 1 minus 0. And we've got it. All right, looky what I have. I've got the identity matrix. That was my goal. I've got this done right here. So if this is the identity matrix, that means this right here is the inverse matrix. I gave us an extra one just in case we needed it. Would have been good to, if I had chosen at the very beginning to swap a couple of rows, which again, totally great idea if you did it. But I didn't, so I didn't need that last matrix. And so my final answer to write A inverse as a nice 3 by 3 matrix. All right, and we are done. So this, you can see, is just mostly just the same thing we did yesterday. Now, I said that the numbers are going to be nicer. Well, let me forewarn you. Again, one of the reasons I like what we do here with this row echelon is you never have to battle fractions. The only time that you're going to get a fraction is if one of these ends up being something other than 1. So let's pretend this ended up being a 5. If this was a 5, then I would take everything in this row and divide by 5. Now don't do it, but I'm going to show you what that would look like. If that was a 5 and I had to divide the entire row by 5, this row right here would not be near as pretty. It would be -2/5, -4/5, and 1/5. And there's a reason I'm telling you this is because it happens on your homework. I pretty quickly on your homework where you're going to end up, your final result will have fractions, and that's okay. You're never having to do anything with them except just write them. You can write fractions. It's okay. It's going to be totally fine. All right. I think that's all I've got for us. I think you're going to do great. Jump in there and get started.